Welcome everyone. This is the question number 9 of the CBSE sample paper 2025, and a point object is placed at the center of a glass sphere of radius 6 cm. The refractive index is 1.5. The distance of the virtual image from the surface of the sphere, okay, that we need to find it out. 4 options are given: 2 cm, 4 cm, 6 cm and 12 cm. Okay, one thing I want to say, we have learned already, that is, if this is the object, okay, then obviously what will happen, the light which is just incident normally, like this, without any change, it will just refracts. But the light which is just comes like this and just falls on it at an angle, if it just comes from this is the denser to rarer, okay, medium, what will happen? Obviously light ray will bend away from the normal. If a person from outside who is in a rarer medium want to observe this, can't observe the P at its position, but observe the P at this position, which is the virtual image of P. So if you say that D is the real depth, then D prime is the apparent depth, and D prime and D is related, okay. D prime is equal to D divided by mu, okay. So optical path is here reduced by the refractive index. Okay, so D prime is the apparent depth, that is the position of the virtual image from the interface, and D is the actual position of the object, okay. So that is the real depth. Here it is said that there is a sphere, okay. I'm trying to draw the sphere. Okay, let us assume this is the sphere, okay, and the object is placed at its center, okay. This is a glass sphere, so its refractive index is obviously 1.5 or 3/2, okay. The object is here, point object, and that point object is here, and if anyone want to see it, then what will happen? Obviously, what is the radius of the sphere? That is actually considered as a real depth. But you know, the observer is outside. That is in the rarer medium. The observer want to see, so he can't see the objects in his place. He will see the virtual image of the object, okay, and that is at a distance D prime, and that D prime we need to find. So D prime equal to D divided by mu. D is equal to R, so R is equal to 6 cm. So that is 6 cm. What is the value of the mu? 3/2 or 1.5. So 6 cm multiplied by 2 divided by 3. So this will become 4 cm. So the answer is 4 cm. Okay. The person will see the point object which is placed at the center. It is lifted by 2 cm. It is lifted by 2 cm, and he will see it is 4 cm depth, not at 6 cm. Can't see the object at its real location. Thank you all of you.